Okay, so as you can see here, here's my circuit to control the servo motor. As I turn this, that will turn all the way back over. There you go, turned all the way over. My potentiometer was acting up only reading values from 280 to 730-ish, so I had to adjust the range when I mapped it. For part one of the digital to analog conversion, I calculated all of the V outs for a 3-bit digital to analog conversion. I used this formula to get these calculations, making the least significant bit 0 volts. Here's my simulation of the R2R DAC. As you can see, the 0th gate is turned on, the rest are off, and it displays value matching up with my calculations. Once again, here's with all the switches closed, matches up with my 111 calculation. After simulating all of the input possibilities, they all matched up with these outputs. So I built my digital to analog converter with the resistors. I used 470 ohm resistors and 1000 ohm resistors because that's the closest I had to having 2R and R relationship. So my voltages were a little bit off when I did this, presumably because it wasn't exactly a R2R relationship. As you can see here on the right column is my output voltages. You can see here, this is in the 111 position. I'm getting a reading of 3.8. You can see my code here. Now it is in the 011 position, and you can see I'm getting a reading of 1.65, just like I had here. My outputs are a little bit off, like I said, because it's not exactly an R2R relationship, so that answers the first question. That's why I wasn't exactly with the simulation. And then also, if I needed smaller step sizes for the servo motor, I would just add more bits. So it'd be 4 instead of 3 resistors going across. And finally, using the DAC that I made here, I pretty much just used the same potentiometer code and just plugged in, rewired a little bit. So here's my 000 position. As you can see, it's pretty much all the way over. I will swap some wires around here to the 111. And as you can see, it goes almost the whole way over. It shouldn't go all the way over though, because it's not getting the totally full range due to the DAC. And finally, just to reiterate, there's 8 different positions that can be oriented by this DAC. In exercise 1, there was 1,024 different positions due to the way the code was written, mapping each analog input to a different specific digital PWM output. If you needed a smaller step size, you would just add more bits, which means add more resistors. And yeah, that's about it. Thank you.